Ladies, your lab for this chapter should be on my weekly with the updated dates. I know at the end of your test, I did give you your lap already. If you were absent for the field trip or for any other reason, of course, you still need to take the test at some point, as well as there should be copies of the lap on my desk if you want that. Again, I believe everything should be online for you for this lap. So we're going to go ahead and get started with 8.1. This video, I'm going to do both at the same time just because it's a little bit easier for me to not stop and re-record. So I'm going to do 8.1 and 8.2 because those are the two lessons that you're going to learn, I believe, on Thursday and Friday, if I remember my dates correctly. So we're going to do 8.1. I'm going to go ahead and finish that. You can pause the video, stop the video, or kind of learn 8.1 and 8.2 all together. And then basically 8.1 and 8.2 will be due next time I see you. All right. So what we have here is we are adding and subtracting polynomials. Okay. So we're going to kind of go through some vocab here. So the first thing is this is 4x squared minus 7x plus 12. And this whole thing we call an expression. Okay. It's good to know these vocab words to know what we're talking about. If we put an equal sign, of course, then that would be an equation. Okay. All right. Next, what we have is we're going to separate these. So if we separate these, as you can kind of see already marked here, in between the adding and subtracting, what we do is we call these terms. Okay. So that's going to be important to know the definition of terms. And in this case, if we counted, we would in fact have 3 terms. Okay. All right. And then lastly here, kind of going through this vocab word, these two vocab words. So with the green numbers 4 and -7, what we're going to have is we are going to have the coefficients. Okay, so it's a number multiplied by a variable. And then, of course, the very last thing where it doesn't have a variable, that's what we're going to call the constant term, and it's a number without a variable. Okay. All right, so we're going to go through again some vocabulary here. So a polynomial, because we haven't talked about polynomials just yet, is an expression with constants, variables, and exponents in the form of ax to the k, where k is greater than or equal to 0. So again, what that says is basically there are no negative exponents, and basically as long as there are coefficients, variables, and exponents, we can kind of make up an expression. Okay. If we were in class, I would ask you what the prefix mono would mean. And so hopefully you're able to tell me 1. So a monomial will be a polynomial with only 1 term in it. Again, I'd ask you what the prefix bi means. So hopefully you could tell me that would mean 2. So a polynomial with 2 terms. And then I would ask what's tri mean, and then again, hopefully you could respond with that it is 3 terms. Okay. I'm going to keep rolling. You can pause this video as you need to write down anything or go back, but I'm just going to keep on going. Let's see if this works. Oh. Well, this is updated. I did not have aliens before, so this is very interesting. Man, I wish this was up so you guys could play with the aliens. This is kind of fun. All right. So I'm going to kind of pick these up, and hopefully I want you to kind of take a minute to respond, and then hopefully you'll kind of see if you're correct or not. All right, so monomial or binomial. So this guy, only 1 term, so this would be a monomial. That's fun. All right. How many terms does this guy have? Okay, hopefully you can say 2. Again, they're separated from adding and subtracting. This one, monomial. This one, binomial. This one, since there's no adding and subtracting, monomial. This one, binomial. This one, binomial. again, just multiplication. So this is a monomial. And then this one. Again, this is 3 squared, which is 9. So this would really be 9x. So this is just, again, multiplication. So that is also a monomial. Oh, that's, I've not seen that. That is definitely a lot more sophisticated than what I had originally. All right, cool. All right. So a polynomial is a standard form. This lesson is very vocab heavy. So it is when the terms are ordered from the highest to the lowest degrees. All right, I'll explain what highest to lowest degrees means here in a second. Okay. All right, so this is an example of a polynomial that's not going to be in standard form. When we're talking about degree, what we're talking about is we're talking about the exponents on the variables themselves. Okay, so for example, this would be degree 1. Okay, this would be degree 0 because there is no variable. Okay, this would be degree 2 because there's an exponent on x, which is 2. Okay, so when we say from highest to lowest, mainly what we say is we mean that the highest degree, so 4x squared needs to go first. Oops. Then 5x, which would be plus. There's a plus in front of that, it's positive. And then minus 6. So this would be in standard form. Okay. You can probably guess that if you had expressions, it's nice to have it in standard form to compare answers, so they're not, just all these terms all over the place. So I will expect you after this lesson to always put your answers in standard form. When I grade, it's easier. When your answers in the back of the book, in standard form, all of that. All right, so hopefully you can take a second to see how you would put this one in standard form. Okay, so we would start with the highest exponent on the variable, which is negative x squared. Sorry, negative 9x to the 6th. Then we're going to do plus 3x to the 4th. Then minus 5x squared plus 7x. And then we have our constant term. Since there's no variable, it goes last, minus 12. Okay, so that would be it in standard form. All right, so again, for your class, I would ask you if you could simplify this at all. So maybe you said yes, maybe you said no, especially coming off of exponents here. But what I like to do is I like to think of cheeseburgers. So this is like saying you have 12 double cheeseburgers, and then you're going to add 3 single cheeseburgers. So if I were to ask you this, would you be able to combine and say, oh, well, I have 15 something, right? You can't really say you have, 15 double cheeseburgers or single cheeseburgers. So in this case, this answer is a no. You can't simplify it. It needs to stay like this because these are not like terms. Remember, we've done that before. Since these are different variables, these are not the same. You cannot add them together. Okay? All right, so mainly what we're doing today is we are adding and subtracting polynomials. So basically what this is doing is just adding like terms. So I would double check to make sure you don't have to distribute anything. So nothing out here, nothing out here. So we can kind of just go ahead and drop the parentheses. And then I'm going to combine like terms. Okay. All right, so I'm gonna look at the highest, look for the highest degree because I need to put my answer in standard form. So I know 3x squared is the biggest, plus 6x squared. I like to circle because I like to keep this sign to the left with that term. So this would be 9x squared. Okay, then we got 7x plus 5x would be 12x squared. And then we have our constants. So negative 10 plus 3 minus 7. And then, of course, that's our final answer. Okay, so So again, if we were in class, I would maybe pause the video and try and do this one first before you see me do it. Try it yourself. All right, so again, nothing on the outsides to distribute. So I'm going to drop the parentheses. All right, and then I'm going to combine like terms here. Now I did change this since plus a negative is, I can just put subtraction, so I did put a subtraction there. Just if you are wanting to double check why I did that. All right, so 8x squared minus 6x squared, 2x squared, 7x minus 8x, negative x, okay? And then constants, plus 2, minus 2, those are actually give us 0, so this would in fact be our final answer. All right, next what we're going to do is we're going to subtract. So again, what I'm going to do is I'm going to double check. Nothing out here to distribute, so I'm going to just rewrite. Okay. Now, the thing is here with subtraction, you do have a negative 1 here, so you're going to have to distribute the negative. What that's going to do is change all of the signs inside the parentheses. So this will be a negative x squared minus 5x minus 3. Okay. Then again, we're going to combine like terms, starting with the biggest power. So 3x squared minus 6x squared would be a negative 3x squared plus 7x minus 5x plus 2x. And then our constants, plus 10 minus 3 minus 7. Okay, again, answer always in standard form. All right, again, I would try this one on your own. So nothing to distribute. So I'm going to rewrite. And then, since we are subtracting, I do have a negative 1. And I'm going to distribute that. So we're going to get plus 6x squared plus 8x plus 2. And then I'm going to combine like terms. So 8x squared, 6x squared. That would be 14x squared. 7x plus 8x, 15x. And then 2 plus 2 would give us 4. All right. Now, ladies, just to kind of, I'm kind of surprised there's no. All right. All right, so as I'm filming this, I'm realizing that I think I'm missing a slide on here. Okay, so I'm going to go ahead and write these examples down. We talked about, polynomial, monomial, binomial, trinomial. And then somewhere in your notes, you'll put this. Really, I'm sure where this slide went. But you're also going to categorize them by the number of terms as well as degrees. So again, that's the exponent on the variable. So if this is degree 0, there's no variable, so we're going to call that the constant function. If there's an exponent of 1, this will be a linear function. If it's 2, it's going to be a quadratic. 3 will be cubic. 4 will be quartic. And I believe 5 and above on Math Excel, you can just say like the 5th degree. All right, so kind of looking at this, what I'm going to do is I'm going to categorize it by degree, but as well as polynomial, monomial, binomial, trinomial, all that kind of stuff. All right. So for this one, I would ask you how many terms you have, which is in between the adding and subtracting. So this is 3 terms. So this would be a trinomial. Okay. Then based on the degree is the highest exponent on the variable, which is 2. So this means that I'm not sure what Math Excel is the order. I don't really mind the order, but it's also going to be a quadratic. So they might have you put quadratic trinomial or trinomial quadratic. I'm not quite sure. Okay. All right, next one. Count how many terms? 1, 2. So this would be a binomial. Okay. Highest degree is 3. So this makes it a cubic. So we're categorizing them in 2 ways. Okay. This one, count the terms. This is 1. So this is a monomial. Okay. There are no variables, right? So that means no exponents. So again, this is a constant term, so that should kind of help you remember that this is going to be a constant function. All right, last one. 2 terms, so this is a binomial. And then that's going to have an exponent of 1, so this will be in fact a linear function. Hopefully you should recognize that. That kind of looks like y equals mx plus b. All right, ladies, so you should be able to do 8.1 homework. I believe it's a worksheet. Okay, I'm going to go ahead and just jump into 8.2 here. So if you're done for today, you can go ahead and pause. And I'm going to pull up the next. Okay, so it looks like this is from last year, so I'll leave this up here for a quick second. I think maybe they had questions on number 50. With this one, you just have to make sure to look at, they have to be the exact same term. So you can kind of see the reds have to be the exact same variables and exponents for you to combine the terms. Okay. You can always shoot me an email if you have questions on homework. I should be able to respond, hopefully. Okay, so what we're going to do is we're going to multiply and factor. So my question, again, I would like you to kind of take a moment and kind of answer it yourself, is for these 2 examples, what would you do with the exponents? Okay, so with the first one, this is x squared times x to the 5th. So this is last lap with the exponents. If you have multiplication and the same base, you add the exponents. Okay. This is this lap where we're throwing in adding and subtracting, where this is x squared plus 5 to the 5th. So this is like a kind of a cheeseburger analogy. You do not have like terms, because remember, these are terms. There are 2 terms here. So really, this just needs to be put into standard form, and you can't do anything with it. Okay? So I want you to recognize that there is a difference between these 2. Okay? So same thing here. I would take a moment, see if you can simplify each of these. So again, with the first one, you're going to multiply the coefficients. Again, vocab word from 8.1. the numbers in front of the variable. Negative 6, y, you're going to add the exponents to the 10. And then for this next example, this has two terms because there's adding and subtracting here. They are like terms, so we can combine them. So 5 minus 3 would give us 2x to the fourth, and you do not touch the exponents. Okay. All right, so what we're going to jump into with 8.1 is we're going to start multiplying. Okay, so I'm going to use a lot of these vocab words. So outside we have a monomial, and the inside we have a binomial. Okay, so what we're going to do is this is basically like distributive property, except we're going to combine last lap with what we're doing right now. Okay, so if we just had the numbers with coefficients, we would do 2 times 3 when we would do distributive property. This would be 6. But then since you're multiplying, you need to add the exponents, right? So this is x squared, and then distribute plus 10x. You do need to ask yourself, do you need to combine like terms? So no, these are not like terms. It's in standard form, so we're done. Again, kind of like if we would do this in class, I would have you do this one. So I would practice this one. So again, we have a monomial times a binomial. So negative 2x times x, negative 2. And then since we're multiplying, we'll add the exponents. X squared, negative 2x times 4 would be negative 8x. Again, they're not like terms, already in standard form, so we're done. All right, next one. We have a monomial times a trinomial. Okay, so we're going to distribute. So multiply the coefficients, 12, and then y, we're going to add the exponent because we're multiplying here. So 2 plus 3 is 5. 2y squared times y, add 2y. Now this is 2 and 1. So this is to the third. A lot of times we'll just write to the second again. 2y squared times 1, just 2y squared. Okay. Again, already in standard form, no like terms, so we're done. Again, I would have you try this one. Again, monomial times a trinomial. Distribute. 15, b to the fourth. 5b, oh, that's interesting. So these are not the same variable, so we're going to just go with that. So negative 5b n squared. Okay. And then 5b times 8 would be plus 40b. Again, none of these are like terms, so we're good. And we're done. All right, so we kind of went forwards where we distribute everything from like a monomial to a binomial, monomial to a trinomial. But what we're going to do now is we're going to kind of go the opposite direction. Okay. So the greatest common factor, so the GCF, this should be reviewed from grade school. It is the highest number that divides exactly into 2 or more numbers. Okay. So I'm hoping that maybe the numbers, you can kind of figure out what is the greatest common factor with the numbers or what divides all of them. But you are going to have to look at the variables and also know what they all have in common. Right? So greatest common factor for this one, so GCF. So we have 5, 25, and 45 for the numbers. So we're going to start there. Hopefully you can answer that 5 divides all of those. All right. Now, I'm going to write this out. Again, in class, I would ask you what these actually mean. So x to the third would mean x times x times x. X squared would mean x times x. X to the first power would in fact just mean x. Okay. Now, again, greatest common factor. Factor is when we're talking about multiplication. Okay. Oops, put the multiplication in the wrong spot there. Okay. So there is a difference between, so the green right here. Oops, I'm putting the multiplication in the wrong spots. Those are all factors. And then remember we talked about terms are adding and subtracting. So there is a difference between the two vocab words, okay? So greatest common factor is that you are looking at what they all have in common, okay? So if you look at it here, there's an x here, there's an x in this one, and an x in this one, okay? So they all have an x in common. So 5x would actually be the greatest common factor, okay? You know, if you're looking at the variables, it's what you can circle or what they all have in common. You can see, hopefully, that they don't all have 3 x's, okay? Some people like to go the reverse way, but you're not picking x to the third. What they all have in common. Okay. So that would be the GCF. All right. So factor the following expressions, okay? So this is where you're going to find the GCF, and then you're going to basically factor it out. You're going to take it out of each of the terms, okay? So let's look at this, GCF. So let's look at the number, or the coefficients. So we have 4, 8, and 12. So the biggest number that will divide into all of them would be 4. Oh, I must have been really not fantastic at typing notes. Let's make that a K. So this is K. This has 2 Ks. This has 3 Ks. So again, my question is, what do they all have in common? They all have 1 K in each term. Okay, so we're going to take 4K out, okay? And what you are doing, oops, you can kind of skip this step, but just to kind of show you what we're doing is we are literally dividing out the common factor. So these should all be able to be divided evenly, okay? You don't necessarily have to write the purple step here, but it might help. So 4 divided by 4 would be 1. Again, you don't need to write the 1. If there's a K and a 3, K to the third, 3 minus 1, or canceling, we're left with x squared. So there's a 1 right here, okay? Plus 8 divided by 4 is going to be 2. Again, you're basically taking out a K, so you're left with K. Plus 12 divided by 4 is 3. K divided by K would be 1. And that would be your factored form. You can also see that whatever you didn't circle is what you end up with as well. So that makes sense. Again, what I would have you do is I would have you try this one. Okay, so GCF, looking at 9, 15, and 12, looks like 3 would be the one that divides all of those evenly. I'm not going to necessarily draw these out this time, but we have x to the second, x to the fourth, and x to the sixth. So I know they all have 2 x's in common, not just 1, but 2. Okay. So I'm going to factor this out. So 3x squared. And I'm going to try and kind of talk through it. So 9 divided by 3 is 3. We took out 2 x's, so we'll be left with x to the fourth. Plus 15 divided by 3 is 5. Took away 2 x's, so x squared. Then plus 12 divided by 3 is 4. And then x divided by x, we're taking away 2 x's, we're left with no more x's. Okay. And that would be your final answer. Okay. You want to try this example? Oopsie. What's going on here? Okay, so if you want to try this question, you already have the answer here. And see if you can figure that one out. Okay. All right, so please, that's the end of 8.2 here. And then you can go ahead and get started on this homework.